Hello, here is another question from Resnick Halliday's 10th edition. It's page number 141 and question number 18. The question reads, you testify as an expert witness in a case involving an accident in which car A slid into rear of car B, which was stopped at a red light along a road headed down a hill, as shown in the figure. You find that the slope of the hill is 12 degrees, that the cars were separated by a distance d, that is 24 meters. When the driver of car A put the car into a slide, it lacked any automatic anti-brake lock system, and that the speed of car A at the onset of braking was v0, that is 18 meter per second. With what speed did car A hit car B if the coefficient of kinetic friction was 0.6 and 0.1? So let's try to solve part A with kinetic friction 0.6. Now the initial speed of car A, this is car A and this is car B. Initial speed of car A is 18 meter per second and car B is stopped at the red light. Now we need to find with what acceleration is car A moving after the brake is applied. So we need to resolve the forces acting on car A. So we'll come back to this diagram again. Now let's try to resolve the forces. Now this plane is inclined at 12 degrees. So it's car A weight will act perpendicular like this. This is mg. And because this is 19, this is 12 degrees, this angle becomes 78 degrees. So component of mg along the inclined plane is mg cos 78, and the component of weight of car A perpendicular to the, this is mg sine 78. Now mg sine 78 is nothing but the normal force N, and this will result in frictional force. The frictional force is acting towards right, and that is mu k mg sine 78. Okay, now after resolving these forces we can write the equation. Suppose and the acceleration of car A is towards left and if that is A. Now the equations that we can write is mu k mg sine 78, so that becomes 0.6 mg sine 78 minus mg cos 78, mg cos 78 equal to minus ma. So you can see m and m gets cancelled and you can get the acceleration by putting the values of g and sine 78 and cos 78. So you get acceleration A as minus 3.71 meter per second square. Okay, so once you get the acceleration, you can use v square minus u square equals to 2as. Final velocity we need to find with what speed the car A hits car B. So that we need to find, and u we already know that is 18 meter per second, so it becomes 18 square plus 2 and acceleration here is basically a deceleration, so it's minus 3.71 times s is 24 meter. They are separated by 24 meter of distance, so v comes out to be 12.1 meter per second. Okay, so that's also part A. In part B, we just need to replace mu k with 0.1, and you will get the acceleration as plus 1.1 meter per second square. And when you use v square minus u square equals to 2as, putting the values of acceleration, and s is here again 24, u is 18, so you get v for part B as 19.37 meter per